over how to complete the prior, conditional, and joint review. Okay, so let's take a look at this first. Right over here. Each salesperson in a large department store chain is rated on their sales ability and their potential for advancement. The data for the 500 sample salespeople are summarized in the following table. Make sure that you pay attention to the bold words, because the bold words will not be on the test. Those bold words are there to help you to know when to use what. Okay, so right here, the very first question says, what is the probability of the first person selected has above average sales ability? So the question is purely, I'm selecting one person. What is the probability that that one person is going to have above average sales ability? And so the total number of people is 500, and the number of people with above average sales ability is 300 right here. So the answer is simply 300 out of 500, or 0.6. 300 out of 500, because there's 300 people total out of 500 people total. So 300 out of 500 is 0.6. Next, given the first person selected is classified as having above average sales ability. So before we do this, before we get on to number 2, what I did here is I made a probability tree. So right here we have all the prior probabilities, and then we have all the conditional probabilities and all the joint probabilities. So you notice down here we have the probability of an individual being above average, which is 300 out of 500, or 0.6. The probability of an individual having average sales ability, which is 150 out of 500, or 0.3. And the probability of an individual having below average sales ability, which is 500 out of, or 50 out of 500, or 0.1. So I've got all the prior probabilities right here. The next question, this little word right here that says given. Given means I want you to find the conditional probability. So given the first person selected is classified as having above average sales ability, so that means that we are only looking at the individuals who have above average sales ability. Out of these individuals that have above average sales ability, what is the probability that he or she will have excellent potential for advancement? So out of these 300 people right here, what is the probability that an individual will have excellent potential for advancement? And the answer to that is, well, let's take a look right here. So you have fair potential for advancement, good potential for advancement, and excellent potential for advancement. So out of these 300 people, the probability of having excellent potential for advancement is 135 out of 300. 135 out of 300, or if you divide that, it's going to be 0.45. So these right here, if I were to say, given that the first person has below average sales ability, what is the probability that that individual will have excellent potential for advancement? So this is saying, what is the probability that an individual will have excellent potential for advancement, given that they have average, or this should say below average, given that they have below average sales ability. And so that would be 22 out of 50, or 0.44. So all of these are saying, given that an individual, what is the probability that they will have fair potential for advancement, good potential for advancement, excellent potential for advancement, given that they have average sales ability, given that they have average sales ability, given that they have average sales ability. So if you want to, you guys can make one of these probability trees on the exam, or you can just understand that this is what it is that it's saying. So use the, so right here, the next question, what is the probability of the first person selected having above average sales ability and having excellent potential for advancement? So what is the probability of an individual having above average sales ability? Okay, so what this is saying is we're going to be looking at everyone. What is the probability that an individual is going to have above the average sales ability, which is right here, 3 out of 500, and of these people that have above average sales ability, what is the probability that they will have above average sales ability and excellent potential for advancement? So this is saying, out of everyone, what is the probability that they're going to have both of these? Okay, so in order to do this, you have to multiply the prior by the conditional to give you the joint. So the prior probability multiplied by the conditional probability to give you the joint, or 0.6 multiplied by 0.45, or you can also just say it's 0.27. Another way to do this, if you want to, is we can say right here the total is 500. So we can do what is the probability that they will have above average sales ability and excellent potential for advancement? What is the probability that they will have both of these out of everyone? So with joint probability, what you can do is literally just do 135 divided by 500. So for joint probability, you can do 135 divided by 500. So that would also give you the exact same number, and that number would be 0.27. Okay. So if I were to say, what is the probability of an individual having above average, or sorry, an individual having average, right here, average sales ability and excellent potential for advancement, then I could just do 45 divided by 500. Or below average sales ability and fair potential for advancement, I could just do 16 divided by 500. But if I were to say, of the individuals who have below average sales ability, what is the probability that, or if I were to say, given the first person, or of the individuals who have below average, either one, but if I were to say, given the first person has below average sales ability, what is the probability that they have a fair potential for advancement? Then you would say 16 out of 50. 16 out of 50, or 0.32. Or if I were to say another way to, given the individuals who have fair potential for advancement, what is the probability that they have below average sales ability? So if I were to say, given that an individual has fair potential for advancement, right away what that's saying is look at this column right, or look at this right here. Okay, of these people, what is the probability that they will have average sales ability? Then it would be 45 divided by 154. So just know what this means. Know when you see given. So given that they have above average, you're looking at this. Given that they have average, you're looking at this. Given that they have good potential for advancement, you'd be looking at this. Given that they have excellent potential for advancement, you'd be looking at this. So just be aware when you see given that it's saying, hey, we're only looking at a small section of people. So the next, like I said, and when you see and, you're going to use the rule of multiplication. If you see the word or, you're going to be using addition. So what is the probability that the first person will be classified as having above average sales ability and good or excellent potential for advancement? So the first thing, what is the probability that an individual will have above average sales ability? That's going to be 300 out of 500. And then it says, and good or excellent. So we're looking at these two, good or excellent potential for advancement. Good or excellent potential for advancement. So you could also just add these two together. So 72 plus 135, which that's going to be 202. So you could say, what's the probability of an individual being in one of these two spots right here? And you could do 202 divided by 500, because that would answer the question. Or the way that this is set up, you would be saying, what is the probability of an individual, given that they have above average? You come over here. What is the probability that they are going to have good or excellent? And then you would just add the two of these together. You would add the two of these together. So if I were to say, what is the probability of an individual having above average and having good or excellent potential for advancement? you would just add the two joint probabilities together, which would give you the exact same thing.